Hello and welcome to my web application series part 3. In part 2, we worked on the user registration handler, where the user could input their email and password to register, and we performed some validation on the user inputs. In this part, we're going to prepare SQLc and Postgres on a Docker container to complete the user registration. SQLc or SQL compiler is a code generator package for Go. It's designed to help developers interact with the SQL database in a type-safe and efficient manner. One of the biggest advantages of using SQLc is that it keeps the SQL and Go code in sync, reducing the chance of SQL query runtime errors. To use SQLc, you first need to install it on your machine. You can go to sqlc.dev website and click on the Get Started button, which will redirect you to the installation documentation. You can install it on major operating systems as well as on a Docker container. Additionally, they have requirement for your Go version, so it's a good idea to always keep it up to date. At the bottom of the page, you have an option to download the pre-built binaries for each operating system. Now we need to create a directory for our SQL-generated code, which I call it DB. In the root directory, we need to have a SQL-YAML file for SQLC configurations. On the first line of the SQLC-YAML file, we need to specify the version of the SQLC configuration format, which is version 2 at the time of recording. Next, we need to define the SQLC files and settings under the SQL section. We need to set our schema path to the schema key. The schema file is where we will define our database schema, including tables, indexes, and so on. We also need to set our SQL query path to the queries key, where we write all our SQL queries. As for the engine, we will set it to Postgres, which is the choice for this project. Next, we have to specify the generation settings under Gen. We set the language to Go and the package name to SQLC. This can be anything you prefer. The out key is where the generated code will live, so we're going to set it to db/SQLC. The good thing about SQLc is that you can choose which SQL driver you prefer to use. I go with PGX version 5, which is completely written in Go. We can also add a bunch of other configurations such as emit JSON tags for adding tags to the structs, which is useful for JSON serialization and deserialization in API calls. Or emit interface. This makes SQLC generate interfaces for our SQL queries, which is very helpful when writing unit tests. And emit empty slices to generate empty slices instead of setting the value to nil. Now we can generate the code by running the sqlc-generate command. However, we are getting an error due to the missing directories. So let's create the directories and other needed files. We can make our first query file, which is for users, and name it user.sql. For the test, I'm going to write a very basic query. Each query must start with a comment that contains the name of the query and the type of the execution. In this case, we are going to fetch all users' records, so we need to specify :many. Now we can create our database schema for the users. This table is going to have basic columns for our users. The email must be unique and the password should be set to not nil. Now if we run the sqlc-generate command, we can see the generated code in our directories. In the querier interface, we can see our SQL query name is generated. And if we go to the users.sql.go file, we have the code that you would usually need to write manually if you don't use SQLc for each table. This code is going to execute our SQL query, put the result in the rows variable, and in the rows.next loop, scan the columns and append to the items which are going to return as the output. One of the easiest and cleanest way to run a Postgres database is to use a Docker container. If you don't have Docker installed, you can go to docs.docker.com and follow the installation steps for your operating system. In this documentation, they cover the installation for major operating systems. You can also find installation steps for Apple Silicon. After installing Docker on your machine, you can go ahead and create a Dockerfile for the Postgres database. First, we need to specify the main image, which is Postgres version 15 on Debian Bullseye. You can find your base image on hub.docker.com. Then we can run apt update and apt upgrade to make sure the image is getting the most recent updates. I'm going to create a directory for our data storage and name it data, but this can be anything. It's not a good idea to hardcode the username and password for the database in the Docker file. So we are going to pass the values as argument and then set the environment variable for Postgres to be able to read those values. First, we need to make sure that we are in the same directory as the Docker file, and then we can build the Docker image by running the docker build command and setting the credentials as arguments. Here is an example of a Docker build error when we set a wrong or misspelled image. If you're getting any error at this stage, it's a good idea to double check your image naming with hub.docker.com. After correcting the image, we can see the Docker image is being built. This may take some time depending on your computer and internet speed. Before running the Docker image, I like to create a bash file to organize all my Docker commands, make it easier and faster to build or run the image during development. I start by creating an empty bash file in the root directory of the project. First, I will write the docker build command, pass the credentials, and set the tag name. If I run the bash file, we should see the Docker build without any errors. Before writing the docker run command, I like to change the image name to ecommerce_image. Now I can write the docker run command to run the image. I'm using the -d flag to run the image in the background and the --rm flag to remove the container after stopping it. If you're unfamiliar with the Docker commands, you can go and check docs.docker.com. The container name will be ecommerce_db_container. And for the port, I'm going to use the default Postgres port, which is 5432. We will use the ecommerce_image that we just created, and now we can run the bash script. To confirm the build and running image, we can run the docker stat command. The result is as expected. That's all for this video, and I will see you in the next one. As always, thanks for watching.